All right, here we're going to do a quick refresher of exponential and logarithmic functions. So whenever we have to graph something and we don't remember what it looks like, the smartest thing to do is probably just create a table of values. So that's what we're going to do. Make a table of values for 2 to the x. Y equals 2 to the x. I usually start at 0 because that's the easiest to plug in. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. And 2 to the third is 8. When we have a negative in an exponent, coming back here to -1, a negative tells us to do the reciprocal or move that to the bottom of the fraction. So 2 to the -1 is 1/2. 2 to the -2 is 1/4. 2 to the -3 is 1/8. Then I can go ahead and put these on the graph. So my anchor point where things normally start at the origin for an exponential function is not actually a point on the graph. The first point on the graph would be over 0 up 1. Then 2 to the first was 2, so I go over 1 up 2. Then I go over 2 up 4. Then I go over 3 up 8 from my anchor point. On the left side of my graph, my y values were the little fractional numbers, and they eventually approach 0. They don't actually get there. They get closer and closer. Because of that, right here at y equals 0, we have a horizontal asymptote. I'm going to fill that in for the asymptote y equals 0. So there's our graph. It does have arrows on both ends. The x-intercept of this graph, there is not one. The y-intercept of the graph would be 0, 1. No matter what number we have to a power, the y-intercept is usually 1, unless we've moved it or something, because any number to the 0 power will be 1. The domain for any exponential functions is going to be all real numbers or from -infinity to infinity, because you can take a number to any power. The range is usually greater than 0, so you could write y is greater than 0 or from 0 to infinity. I'm going to put from 0 to infinity. Notice there's a parenthesis over here on the left side because I don't actually equal 0. It is my asymptote. Number 4 says, is 2 to the x exponential growth or decay? I am increasing as I go, so this is called growth. Lots of things in the real world grow exponentially. All right. If you were doing any other exponential function, just remember that all exponentials will have the same general shape as our y equals 2 to the x. If you're trying to decide how high up to go on each point, you just need to think of whatever the base is raised to its exponents. So if you have a 3 to the x, you're going to raise 3 to powers. If you have a 5 to the x, you're going to raise 5 to powers. But all the graphs will look similar. It's just going to vary how high up each of these points goes, depending on what you're taking to a power. All right, that was exponential functions. The next part are logarithmic functions. We remember that logs are the inverses of exponentials. Logs we write with a little base. The log base 2 of x is the inverse of y equals 2 to the x. If I had a different base in my logarithm, it would just be the different of that inverse base. All right, so if I'm going to make my table, log base 2 of x is the inverse of 2 to the x. So I'm just making the same table I made for 2 to the x. I'm writing the numbers down in the opposite order. I say 2 to the 0 was 1, 2 to the first was 2, 2 to the second is 4, 2 to the third is 8. I'm simply writing the x values down in the y column and the y's down in the x because I'm doing it in inverse. So 2 to the -1 is a half, 2 to the -2 is a fourth, and 2 to the -3 is 1/8. So let's go ahead and plot this one. Now I've switched x and y, so I'm going to have a vertical asymptote at x equals 0 instead of y equals 0. My points, instead of going over 0 up 1, I go over 1 up 0. The next point would be 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. I'm just putting them in the opposite direction. For a log, I've got the little tail that goes down. So on this one, I have an x-intercept of 1, 0. I have no y-intercept. My domain is restricted from 0 to infinity, which was my exponential's range, and my range is from negative infinity to infinity, which was my exponential's domain. Remember, you cannot take the log of a negative number, which is why it's only on the right side of the graph. One last bit here, if we were to do a log of something else, and we're going to transform it as well. I'm sorry. So on this one, my base is a 3. Since my base is a 3, I'm going to think of 3 to the x when I'm making my table. So 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. Over here on the negative side, I'd have 3 to the negative 1 is 1/3, 3 to the negative 2 is 1/9, and 3 to the negative 3 is 1/27. All right, so that's my parent function right now. This is y equals the log base 3 of x. I need to do some transformations to that. I have a +2 on the inside, which is going to move me 2 to the left, and a -4 on the outside, which will move me down 4. So I go 2 to the left and down 4, and that's my new anchor point for this graph. For a log graph, wherever my anchor was, I have an asymptote. Then I'm going to count out my parent function point over here. So I'm going to go from my anchor point over 1 up 0, from my anchor point over 3 up 1, from my anchor point over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2. And then those little points I don't necessarily plot, they just sort of trail on down along there. By the way, this was the table over here for our parent function. On your practice, you're going to have to do some other tables. If I wanted to do the table for y equals the log base 3 of x plus 2 minus 4, just realize when I'm making my table, all my y values had a -4 with them. So I'm just going to take my y values and subtract 4 from them. So that would be -7, -6, -5, -4, -3, -2, and -1. My x values, I have a +2 on the inside, which moves me 2 to the left. So I'm going to subtract 2 from all of these x values. So if I subtract 2 from 1/27, I have -1 and 26/27. If I subtract 2 from 1/9, I have -1 and 8/9. Subtract 2 from 1/3 is -1 and 2/3. Subtract 2 from 1 is -1. So this right here, this -1, -4, if I look over here in my graph, that was my first nice point I put on there. So if you don't want to put the fractional points in the table, that's fine with me. Subtract 2 from 3 was 1. Subtract 2 from 9 was 7. That was the last point that fit on the graph. And subtracting 2 from 27 gives me 25. And if you look at these points right here, they are all the points that appeared on your log graph. All the transformations for logs and exponentials are just like the other ones. Anything inside a logarithm that's inside the parentheses is going to affect us left to right. With an exponential function, the inside would be up here in the exponent. So anything written small would be on the inside, and that would affect us left and right. Anything on the outside or written full size would affect us up and down. On the log, it would have to be written outside of the parentheses.